Okay, so this video is for section 2.2, and I'm going to do a couple things in this video. Like I did when we were programming the quadratic formula on the calculator, I'm going to sit down and I'm going to hold the calculator right in front of the camera so that you can see what's going on with the calculator. Because chapter 2 is heavily dependent on the graphing calculator, so it's important that you understand how to use it. Once we get through that, then I'll come back to the board and we'll go over a couple problems from the textbook. All right, so let's take a look at the graphing calculator here. If you've used it before, that's great. If not, then please pay attention to what's happening here. So let's see here. First, let's get the camera to focus. There we go. So the thing that I want to point out to you here is these white buttons right here. If you've got the older model, the black calculators, they're not, these buttons are a slightly different color, but it doesn't make any difference. So it's those 5 white buttons directly under the screen that I want to call your attention to here. You've got the Y equals button right here. Right, and then you've got the window button, the zoom button, the trace button, and the graph button. And I'll talk about each one of these individually, okay, as we go through this. So the first thing, if you want to make a graph, then hit the Y equals button right here, okay? And that brings up a screen that looks like this. Okay, so now if we want to graph something, like let's say we want to graph, let's say we'll do problem 2 on page 91 here. So this is 24x to the 4th plus 5x squared minus 13x plus 3. Okay, so this is number 2 on page 91, 24x to the 4th plus 5x squared minus 13x plus 3. And now if we want to see a picture of this graph, then we go over to the far right side here and we hit the graph button. Okay? And there's what my screen looks like, and there's the calculator drawing a picture of the graph. It's a pretty simple graph. Okay, now if your window doesn't look like this, there's a couple of things that you can do. One thing that you can do, and I do this a lot, is the zoom. If you hit the zoom button, choice number 6 says Z standard. That's zoom standard. And so you can just hit the number 6 if you want to, or you can arrow down and choose zoom standard. Okay, so what that'll do is that puts you into the standard window where the x's range from negative 10 over here to positive 10 over here, and the y's also go from negative 10 down here to positive 10 up here. So if you've got a different window and you want to change it back to the standard window, you can always choose zoom number 6, zoom standard. If you want to do this yourself, if you want to do it by hand, you can hit the window button right there, okay? And then the important things here are, you can see the x minimum and the x maximum. The scale is not that important, and then you've got the y minimum and the y maximum there as well. And you can see how they're both running from negative 10 to positive 10. And I've set up all of these problems so that what's happening in the problem will always be happening in this standard window from negative 10 to positive 10 on both the x's and the y's. Okay, let's see here. What else do we want to talk about? If we go back into zoom, something else you can do when you hit zoom that I use a lot is choice number 1, zoom box. Okay, so if we hit enter here, when you come back to the screen, you can see that cross. The cursor is now a cross that's blinking, and you can move it around by hitting the left and right, up and down arrows. So I just moved it down and to the right, and there it is. And what we can do with this is we can create a new window by making a box around the portion where we want the new window to be. Okay, so the thing is, we're going to use that cursor to set a corner on the box. Let's say I wanted a corner of the box to be, let's see, right there, okay? Once I do that, I go down and hit enter, okay? Doesn't look like anything happened, but now when I hit the arrow keys, if I arrow up, see how it opens up, and if I arrow to the right, it'll open a box to the right, and if I go to the left, it'll open a box to the left, okay? And then if I hit enter, that's going to be the new window. And let's see, where's the graph? There it is, okay? Okay, now, in section 2.2, what we're going to be doing is finding the roots for these equations, okay? The roots are the x-intercepts. They're also sometimes called zeros, all right? So, to find these, get the calculator to find these for you, what you want is this calculate menu. See right here where it says calc, right above the trace button. Okay? So to access that, you want to hit the blue second key, which is right here, second, trace. And there's the calculate menu. Okay? Choice number 2 is find the zero. All right? That's another word for the root. And again, you can just type in 2, or you can arrow down and hit enter, okay? Now, if you do that, the first thing it's going to do is it's going to ask you for a left bound, all right? So, let's say we're interested in this root right here, all right? If you go to the left of the root, the curve is up here. That's where your left bound is going to be, okay? So, we don't know where the cursor is because it's off the screen, but it tells you right here the cursor is where x is negative 0.07, y is about 4, okay? So we need to bring it, I'm using the right arrow key, I'm going to bring it further to the right, you can see it's changing, and then there it is in the screen, okay? So any points up here, right along that curve right there, those are good left bounds. Once you pick one, hit enter. Now it's going to ask you for a right bound. Okay, so we're still interested in this root right here. If you go to the right of the root, down here are where the right bounds are. So again, I'm going to use the right arrow key. You'll see the cursor move, and there it goes. These are all right bounds for that root. Hit enter. Now it's going to say guess. Okay, we don't really need to worry about that. I'm just going to hit enter one last time. And when I do that, now it says 0. That's how you know you've got the answer. And the answer here is about 0.268 approximately. Okay? All right, let's find the other root. So we hit second, trace, find the 0, choice number 2. Okay, so we've already found that root. Now if we want to find the other root, if we want to find this root over here, okay, now if you go to the left of the root, the curve is down here. This is where the left bounds are. If you go to the right of the root, the curve is up here. That's where the right bounds are going to be. Okay, so left bound, I'll arrow my way over there and hit enter. And now it's asking me for a right bound, so I'll just go on past it using the right arrow key. There's a good right bound. Hit enter again. See how it says guess? We don't want the guess. We want to know exactly what the answer is, and there it is. The 0 for this function is 0.592 approximately. Okay. So those are the basic ideas of using the graphing calculator. If you have questions as you're going through the problems, let me know, and I'll be happy to talk with you about it or email with you about it. Let's look at a couple problems. Let's see here. Got to get the camera to refocus on the board. Let's see if I can do that. I think I might have to write something on the board. Okay, so these problems are on page 91. Okay, there we go. Now I've got the camera focused on the board again. And let's look at a couple examples on page 91. So problem 4 says 2x cubed plus 5x squared minus 15x plus 7 equals 0. Okay, so the idea here is I'm going to hit the y equals button, and I'm going to type this in, not the equals 0 part, just this part right here. So 2x cubed plus 5x squared, let's see here, cubed 5x squared minus 15x plus 7. And then I'll graph this in the standard window. So the x and y's will run from -10 to +10. And if I do that, I get a curve that looks something like this. Disappears off the screen, comes back on, disappears off the screen down here, it comes back on again. Okay. If you want to get a little bit better view of this, you can increase your x maximum and you can decrease, your y maximum, and you can decrease your y minimum if you want to see the places where that curve is connected. Let's see here. Let me go ahead and do that. I'm just going to go into my, if you hit the window key, I'll make the y minimum -15, make the y maximum +15. And let's see, do we get a better look at this? More or less. If we do that, we get to see the top, but this doesn't really change a whole lot. And that doesn't even really matter. What we're interested in are these roots right along here. Okay? So what we're doing with this is we're graphing y equals 2x cubed plus 5x squared minus 15x plus 7. And as you know from graphing, right, every x coordinate that you input in here gives you a different value for y. What we want to know is what's the x value that's going to make y equal to 0, because that's going to happen here, here, and here. Okay? And that's what the calculator can tell us by using that 0 function. Okay, so we'll do the first root right here. It doesn't matter which one you do first. I'm just going to start with the leftmost root. And let's see here. That one happens to be -2.034. This root right here. See here. Now, I can arrow my way over there, and I can put a left bound up here, and I can put a right bound down here. The other thing that you can do with the left bound and right bound, and I'll show you this, I'll bring the calculator up close to the camera again just to show you how this works, is you can just type in x values for the left bound and the right bound. Okay? So let's take a look at this. Let's see. Okay, so now I've got the camera focused on the calculator, and again, we want to hit second, trace, number 2, and now it's asking us for a left bound. Well, you can see clearly that 0 is to the left of that root, so you can just type in the number 0 as your left bound right there, and then hit enter. Okay, now it's asking you for the right bound. You can see 1 is to the right of that root, so you can just type in the number 1 as your right bound. And there's what it looks like. And then hit enter again. You'll still get that guess feature. We can just hit enter one more time, and there's our answer. It's at, the root there is 0.418 approximately. So that's just another way of going about entering the left and right bounds. Okay. Let's see here. So what was that? That was 0.418 right here. And these are all approximate because they're irrational numbers. And then we'll go in, we'll find this third root out here. Let's see here. So this one I'll arrow over. I'll set a left bound down here with the arrow keys. Let's see here. There it is. Hit enter. Set a right bound would be up here. So we could just go past the root. There it is. And then that'll be 4.116 approximately. Okay, so there's 3 roots. This is a cubic equation, x to the 3rd power. It can have up to 3 roots. That's part of what's called the fundamental theorem of algebra. I'll talk about that a little bit as we go through chapter 2. It comes up from time to time as to how many roots are these equations going to have. Okay, so that's problem 4. Let's take a look at problem 6. Let's see here. So we're still on page 91. Problem 6 is x to the 4th plus 2x cubed plus x squared minus x minus 6 equals 0. So to solve this, we're going to graph the equation and then look for what x values are going to make y be 0. Okay, so x to the 4th plus 2x cubed plus x squared minus x minus 6. And if we look at this in the standard window, it's going to look something like this. Okay, so we've got 2 roots. So this is y equals x to the 4th plus 2x cubed plus x squared minus x minus 6. And these are the x values here and here that make y equal to 0. So let's go in and find the zeros. Set a left bound and a right bound here. Oh, and this is exactly equal to -2. And let's see what the other root is. That one looks like it's not an exact value. Let's see. Yeah, it's about 1.213. Okay, and we'll talk more about what makes these roots have the values that they do as we work our way through chapter 2. Okay. So that's for this section. All we really want to do is we want to be able to use the calculator to find these roots. We'll move on from this. Okay, in section 2.3, you'll see how we combine what we did in section 2.1 and section 2.2. Okay, but we'll save that for a little bit later. Let's see. Let's look at one more of these problems. Problem 8. So problem 8 is 2x cubed minus 5x minus 3 equals 0. So let's look at the graph for this one. Let's see, 2x cubed minus 5x minus 3. We'll look at it in the standard window. And what does it look like? It looks something like this. So it's kind of hard to tell. Here, let's just go and find this root. Okay? We'll set a left bound, set a right bound, and this is about 1.823. Okay, now, what's happening over here, it's kind of hard to tell. Okay? So let me bring the calculator over to the camera again, and we'll see what's going on with this. All right, so here's the calculator. Let's get the camera to focus on it. There we go. And you can see over here, it's really kind of hard to tell what's happening. You can't tell, is there one root there? Are there two roots there? Are there no roots there? Does it touch the x-axis at all? Does it touch it once, twice, or no times? So what I'm going to do is I'm going to do a zoom box. Okay, so if we go into the zoom feature, remember choice number 1 is zoom box. And so there's the little cursor. And now what I'm going to do here is I'm going to arrow my way over there and then put a little box around this section that we want to see better. So there's the upper left-hand corner. I'll hit enter, and then I arrow down, and then go over, and now I've got this box opened up. And we'll get a much better look at that part of the graph. Okay, so there's our window now. Ooh, it looks like it's intersecting twice. I'm actually going to do this again. I'm going to do another zoom box and get a better look at what is actually happening here. So there's the upper left-hand corner. Go down and over. And now there's that. So now you can see much better. Okay, yeah, there are two distinct roots there. Okay, and so what I'll do now is I'll just do that process where I use the find the zero. You hit second, trace, choice number 2, and let's see here. Set a left bound and a right bound, and then we've got one root at -1. Well, that was nice. We've got one root at -1, and then let's see what the other root is. And that root is 0.823. 0.823. So we've got 3 roots. 2 of them are irrational values, and one of them, like I said, is a rational number. Okay, so like I was saying earlier, as we work our way through Chapter 2, I'll talk more about what produces rational versus irrational roots, and we haven't even gotten into the issue of the possibility of complex roots. We'll save that for the end part of Chapter 2. So so that is enough for you to do the quiz that covers sections 2.1 and 2.2, and then I'll make a new video for section 2.3 where we combine these two ideas of finding these roots and representing those intervals.